Today, I wanted to go over what I think is the best way to structure your API projects. This is going to be a pretty opinionated video, so you might agree with it, you might not. Let me know what you think down below. So I think when you're building an API in .NET, you have 4 different options. And you have the choice between controllers and minimal APIs. And you also have the choice between grouping by resource and using endpoints. So if you wanted to use controllers and you wanted to group by resource, you can just use the standard controller approach, which is a controller that has multiple actions in that controller. But if you wanted to do a more endpoint approach while still using controllers, you can use a package like API endpoints, which allows you to use controllers but still structure your application like endpoints, where each endpoint is its own separate thing. However, if you wanted to go down the minimal API approach, and you wanted to structure it like controllers and grouping it by resource, you can use route groups. And I've shown this in a previous video, so I'll link to that below. What I think is the best approach is using endpoints while still using minimal APIs. The reason why I think minimal API endpoints is the best is because we can actually build these isolated units of work that encapsulate everything that the endpoint requires. So our endpoint is going to define our request and response contract, any validators, and then also encapsulate the logic for that endpoint. Now, in terms of folder structure, these are some of the common folder structures that I see people using. So the first example is by technical concern. So this is like grouping things by what they actually are. And then we commonly see clean/onion architecture. So like grouping things by like API, application, domain, infrastructure, and managing how those dependencies are pointing in certain directions, usually by creating multiple projects and all that sort of stuff, right? And then this is also what I commonly see is like domain-driven design plus vertical slice architecture, where we're grouping things by features, but we're still doing domain-driven design. So we have our domain folders with our domain objects and domain services and all that sort of stuff, right? So these are all perfectly valid architectures, folder structures, whatever you want to call them, right? But we're not going to be using anything like this today. The only thing that we are going to be using is something like vertical slice architecture, where we're grouping by features, but we're not doing domain-driven design. So this is how we're going to be structuring our application. One of the main things that I wanted to achieve with this structure is simplicity. So first off, we have this endpoints file. This endpoints file is going to give us an overview of our entire API surface. So I don't want to have to dig through controllers or dig through folders to find all of my use cases in my application, right? I want to know really easily what my API can actually do. Next up, we have our common folder. So in any application, you're going to have some sort of common functionality or some sort of code that you want to reuse across multiple parts of the code base. This is where you put it. Next up, we have our feature folders. So like vertical slice architecture, we are going to be grouping by feature. So the main point behind vertical slice architecture and using feature folders is things that change together should live together. What does a feature folder look like? Well, it can contain common services that are used across multiple different endpoints. And then we have our endpoints folder. So this is all the endpoints that belong to this particular feature. So this feature group, for example, posts, we could have multiple endpoints, such as like get post by ID, delete post, archive post. One important thing to note is each endpoint is going to define their request and response contract. And this is going to be really key in creating that isolated piece of work just for that particular endpoint. And finally, we have our data folder. This is probably where I'm going to diverge a little bit from most of the other examples and get a little bit opinionated here and go against the grain, because we're not going to be using domain-driven design. So I've used domain-driven design in the past, it's worked, but it's always felt a little bit too complicated than what it actually needs to be, right? And the main purpose behind this is simplicity. So rather than creating this rich domain model where we're trying to shove our behavior into particular domain objects and then eventually thinking, wait, does this behavior belong in this object or this object? We're going to be doing the complete opposite of that and just letting data be data. And what I mean by that is just creating classes, creating records with simple properties and adding behavior when it makes sense. And the reason for this is because I've been experimenting a lot with Golang and I've been consuming a lot of Golang content. The idea of having these simple structures and then creating functions to operate and manipulate that data, it just really resonated with me. So I started experimenting with that same approach in .NET, and when I started doing it, it just felt really simple, and it was really nice to just build these applications without having to try and figure out, hey, does this behavior live in this domain object or this behavior live in this one? It was just nice and simple where we just had our data structure and then we had these methods to operate over them. And usually this functionality and these methods operating over our data is going to be our endpoints, right? Because that's the functionality of our system. That's the use cases of our system, and we're just operating over our data types. So now that you've seen an overview, let's take a look at what it looks like implemented. If you guys want to take a look at the source code yourself, it is on my GitHub and I will put a link in the description. But for now, let's open it up in Visual Studio, take a look. So this is our solution. Let's take a look at some of the top level stuff and see how it maps to our overview. So we have our endpoints file here. This is going to give us the overview of what our API can actually do. We have our data folder, which is going to contain all of our stuff to do with our database, and it's also going to have our types. So you can see we have types like post, user, like, comment, all that sort of stuff. And then we have our common folder, which is going to contain some of our common logic. And at the moment, all I've really got in here is our API. So we have some common extensions, we have some common filters, and then we have a common endpoint that we're going to be using across all of our endpoints in our application. And then we have some feature folders, right? We have authentication features, we have comments features, we have posts features, and these are all going to contain endpoints, right? So if I expand this, you can see our post will have endpoints, and these are all of the endpoints that our post feature contains. So let's actually take a look at our endpoints file. So this is just a basic static class with a extension method to map the endpoints. We're just setting up some basic security here, and then we're creating a root endpoint group, and then we're actually creating our endpoints, or we're mapping our endpoints, I should say. So as you can see, this gives me a really quick and easy way to just see all the functionality that our API can do. So let's actually take a look at an endpoint. So let's have a look at get post by ID. Back to what I said in the overview, an endpoint is a self-contained unit of work, and it's really broken down into three things. So the first step is endpoint mapping. So what we're going to be doing is defining what is the request method, and then what is the route. So in this example, we have a get request and the route is ID. And then also a part of this mapping is we're providing some sort of documentation here, and then we're also mapping an endpoint filter for request validation. And that brings us to the second key thing of endpoints, which is describing the request and response contracts. We have a request and we are required to provide an ID, and then we actually describe the response. So this is going to be the shape of the data that we're returning from this endpoint. And the final thing, and probably most important, is the actual logic. How are we taking in this request and how are we generating the response? So since we're using minimal APIs, right, we can just provide static methods as our handlers. So I have this handle method, and you can see it's returning a OK of type response, or it's returning a not found. And since we're using static methods as well and minimal APIs, we can actually inject dependencies into these methods without using constructor injection, for example. And then we just perform our logic, right? So we get our post from our database with the particular ID, selecting all the columns that we actually need from our database, and then we are returning our result. So an endpoint is really simple. It's really just broken down into those three things. If I'm to open any one of these endpoints, let's say if I go to comments and I go to our create comment, right? We have our mapping, we have our request response and any validation that we need, and then we have our handler. It's really that simple. It's broken down into those three things, and it's all self-contained. It's all encapsulated inside of that particular class. Now, the one thing I wanted to go over a little bit more was the discussion around the data and just letting data be data. So here we have a post, right? It's just a plain old class with no behaviors whatsoever, just properties. So I think it's totally up to you whenever you want to add behavior to a class. I'm never going to say, don't ever use methods on a class, because you're just going to disadvantage yourself way too much. Only add behavior when it makes sense. Let's say I wanted some functionality to get the number of days since this post was created. Now, I could create a method in another class for that and pass in the post, or I could just put it directly on the post because it's asking a question about its own data. An important thing that I wanted to end on is architecture and project structure is not a silver bullet. It's not going to make you create the perfect application, right? All an architecture and structure does is point you in the right direction using some sort of guiding principles. So I hope you guys enjoyed the video. As I said before, GitHub repo is in the description below. Hope you guys enjoyed. See ya.